All right, hi you guys. Here's our second video for week 2 of distance learning. We are continuing with multiplying radicals today, only this time we'll have variables in it. And by the way, I don't know how much background noise this video picks up, but just so you know, all 4 of my older children are either on group chats with friends, playing on Xboxes or their PCs or something with their friends, and they're loud. And I keep telling them to stop yelling, and they aren't listening. And my 7-year-old wants to tell you something. Okay, say it.
I'm making a present for my friend's birthday because his little sister's turning 3 years old.
Yeah, but can we go to her birthday party?
No.
No, right? But we can give it to her at the door. Yeah, okay, thank you, babe. Okay, so now that you have the update of how my house is going right now, let's do your math. Just like Monday's lesson, this note sheet is combination notes and practice problems. I didn't really feel like you needed tons of notes and tons of practice problems for this lesson, so we're going to do the same. I'll do one example from this top section. And one example from this bottom section. And then you can do the remainder of the problems on your own and check your work with the filled out notes. That's in Google Classroom. So the difference in today's work is this. On Monday's lesson, you might have had, something like the cube root, 6 cube roots of 4 times -3 cube roots of 12, something like that. Today we're just adding variables in and talking about how that makes a difference. Like we might have m to the 4 here and m squared. All right, that's the only change. The steps are the same. First, you check that the roots are the same. Second, you multiply what's outside the radical and you multiply what's inside the radical. Let's take a moment right here to talk about multiplying variables. Remember, if you are multiplying m to the 4th times m cubed, or sorry, m squared, the rule is that you add the exponents, m to the 4 plus 2, or m to the 6th. And then you simplify the radical. And when simplifying variables in the radicals, you simplify groups of variables that are the same size as the root. So like if we go with this same example that I already wrote up top here, if you were doing the m4 times the m squared, and you've got a cube root of 3, and never mind the other numbers for right now, I'm just looking at the variables only, and you had the cube root of m to the 6th, remember that means you have 6 m's, and you're trying to simplify groups of 3. So there's a group of 3 m's, and there's a group of 3 m's. You pull out 1 m for the first group, 1 m for the second group, and that would be m squared, and that's how you would simplify that radical. So you're looking for groups of 3. So that's our goal for today. So looking at example 1, step 1 is to check that the roots are the same, and they are. Step 2 is to multiply what's on the outside, so that's 10 times 4, which is 40, and then multiply what's on the inside of the radical. That's 6 times 3, which is 18, and then p cubed times p, which is p to the 4th. And then the third step is to simplify the radical. So we're trying to look for perfect squares in 18, and there is a perfect square of 9. So I'm going to factor 18 as 9 times 2, And then I want to break up the p to the 4 in groups of 2. So p to the 4 has 2 groups of 2 like that. And then I'm going to simplify those. I'm going to bring 3 out for the square root of 9. And the square root of p squared is p. And the square root of this p squared is p. So I have 40 times square root of 9, which is 3. The square root of the first p squared is just p. The square root of the second p squared is p. So that's all on the outside. So that went here. That went here. The square root of that went here. And then the square root of whatever's left inside, which is just that 2, that's all by itself, right here. So now I just multiply these things together. 40 times 3 is 120, and then p times p is pp. Haha, just kidding. I mean like the p that you do in the toilet, which doesn't really improve the situation that I just explained it, but anyway, moving on, sorry. 120, p times p is p squared, and then you have the square root of 2. Okay, so that is an example where you have square roots. And don't forget, I did kind of a little bit of ninja style there. You are always, always welcome to do a full-on factor tree wherever you need. If you were doing a full-on factor tree here, from this step, it would look like this. 40 times 18, which is 2 times 9, and 9 is 3 times 3, and then 4 p's. And you would be looking for groups of 2 because you're taking a square root. And so here's a group of 2 that comes out as 3. Here's a group of 2 that comes out as 1p. And then here's a group of 2 that comes out as 1p. Okay, and then you would get here next from that step. Okay. So you can try 2 and 3 on your own. They're both square roots. Let's look at number 4 down here. Everything on the bottom is 4th roots. Step 1 is the same. Check that the roots are the same. They are. They both have 4th roots, so that checks. Step 2 is to multiply the numbers on the outside. So that's 2 times 3, which is 6. And then multiply what's on the inside. That's 20 times 28. So 2 times 28 is 56. And then just add that 0 at the end. That's 560. And then y squared times y cubed. Your base is y. You're adding the exponents. It's to the 5th, right? And then the last step is to simplify the radicals. Ninja style looks like this. 16 goes into 560, and that has a perfect 4th root of 2, because 2 times 2 times 2 times 2, in other words, 2 to the 4th, or 2 times itself 4 times, is 16, times 35 times y to the 4th times y. So here I'm already just looking at the y to the 5th and breaking it up into a factor of 4, y to the 4th, and then it had 1 y left over. And so then here's how you simplify. The 4th root of 16 is 2. So 4th root of 16 simplifies to 2. The 4th root of y to the 4 simplifies as y. And then you still have the 6 on the outside. So 6 times 2 times y. And then times the square root of whatever's left inside. which was 35y. And then that's going to give you 12y times 35y. And I just realized looking at your notes that I was going too fast and I put 12y squared. That is wrong, and I will make a note in somewhere in the Google Classroom to let you know that. And if you wanted to see this worked out with a factor tree, if you're done with Ninja style is good for you, you can stop the video right now. If you need to see factor tree style, that would look like this from this step right here. 6, this is going to be long, times the 4th root of 560 is 2 times 280, which is 2 times 140, which is 2 times 70, which is 2 times 35, which is 5 times 7. Those are primes. And then you'd have 5 y's. And you'd be looking for groups of 4. So you'd have 4 2's right here, and 1 of those would come out of the radical. And you'd have 4 y's right here, and 1 of those will come out of the radical. You'd multiply times the 6, which is already outside the radical. And then you'd have 5 times 7 left over inside. And then you'd have the same answer. All right, so there you go.